You wake up, your phone downloaded a patch overnight, the icons are maybe, slightly rounder, and you just move on with your day.
Right. It's complete invisible magic.
Exactly. But I want you to imagine a world where updating your software required a 495-pound capital investment, 2 physical floppy disks, and like a laser-burned DRM system that literally held your computer hardware hostage.
Yeah, that's a very different reality.
Welcome to the Deep Dive. Today we're pulling a primary source out of the archives, which is a 1984 issue of Personal Computer World magazine.
It's a fantastic issue, too.
It really is. Specifically, we're looking at this sprawling review by Kathy Lang. It's titled dBASE Joins the Family, and it explores a piece of software that essentially built the modern world of data, which is dBASE 3.
It's a crucial document. I mean, if you want to understand the architecture of the data-driven systems running our lives right now, you have to look at the constraints engineers were fighting 40 years ago. The rules of modern database management were forged in this specific era under these really specific, brutal hardware limitations.
Okay, so let's unpack this, because setting the scene of 1984 computing is essential for you to really grasp what's happening here. Ashton-Tate, the company behind dBASE, is an absolute software titan at this point.
Oh, they were massive.
And they had captured the market with their previous release, dBASE 2, which was notorious. I mean, everyone acknowledged it was powerful, but it was also famously hostile to anyone who wasn't a dedicated programmer.
That hostility was almost a badge of honor in the early 80s. The assumption was that if you were, touching a database, you were a systems architect.
But the personal computer market is shifting.
Yeah.
We have the IBM PC and MS-DOS compatibles suddenly flooding offices.
Right, the beige boxes are everywhere.
Yeah. Lang's review specifically mentions machines like the Apricot PC getting an early version of dBASE 3. Businesses are buying these things, putting them on desks and saying, okay, compute something.
And Ashton-Tate answers with dBASE 3, but the barrier to entry is still shocking.
It really is. Let's talk about the physical reality of getting this program to even run. You drop 495 pounds, which is an astronomical sum for software at the time.
Adjusted for inflation, it's a huge investment.
Massive. You get a heavy physical manual and 2 floppy disks, and then you immediately run into the PROLOK system.
The PROLOK system is a perfect example of machine-level friction.
Explain that, because it's wild.
Well, today, digital rights management is just a background process, right? It's querying a server somewhere. In 1984, the DLM was intensely physical. PROLOK meant you were obligated to have the master system disk physically sitting inside floppy drive, just to boot the software.
Wait, so you couldn't just copy the files to your hard drive and put that expensive master disk somewhere safe in a drawer?
Exactly the opposite. And the underlying mechanism here is just fascinating. To prevent casual piracy, companies like Volt Corporation, who created PROLOK, would take the physical floppy disk.
The actual plastic and magnetic disk.
Right. And they would use a laser to burn a microscopic hole, or like an imperfection, into a very specific, unreadable sector of the magnetic platter.
So it's not some hidden software code you can copy. It's actual physical damage to the disk.
Yes, deliberate, calculated damage. When dBASE 3 started up, the software would instruct the mechanical read head of your floppy drive to move over to that exact sector and try to read it.
And if it read data.
If it successfully read data, it knew it was a pirated copy because a normal copied disk wouldn't have the laser hole. It expected the read error. It was literally checking for the physical absence of magnetic material.
That is insane. The software is interrogating the physical world to ensure you have the right to use it.
Exactly.
But, I mean, that also means if your floppy drive misaligns or if you accidentally scratch that master disk, your 495-pound investment is completely useless. You're locked out of your own business data.
Which really highlights a broader philosophy of the time. You didn't just own software, you maintained a delicate, almost fragile relationship with it. The physical limitations of the hardware dictated every single aspect of the user experience.
And that physical hardware constraint brings us to the actual battlefield dBASE 3 was walking onto in late 1984. Because Ashton-Tate wasn't just competing against other databases.
No, they were fighting a war on 2 entirely different fronts. It was a very polarized market.
Right.
On one end, you had the heavy-duty professional systems. Kathy Lang specifically calls out programs like Sensible Solution and Aspect in her review.
And who are those built for?
They were aimed squarely at professional systems developers. These were environments that offered incredibly robust database facilities, but they offered zero hand-holding.
Not at all.
Like, they assumed the user was was writing complex, multi-layered code from scratch. If you weren't a hardcore programmer, you couldn't even get past the command prompt.
But then on the completely opposite end of the spectrum, you had this massive industry trend happening. The big buzzword of 1984 was the integrated package.
The attempt to build the Swiss Army knife of software.
Exactly. Programs like Lotus's Symphony or even Ashton-Tate's own internal rival framework. The pitch was incredibly seductive to a business owner.
I mean, why buy a word processor, a spreadsheet, a graphing tool, and a database separately?
Right. Buy one integrated suite and you get it all mashed into one seamless interface.
The marketing was brilliant, but the underlying engineering contained a fatal flaw. And this is where we hit the core conflict of the 1980s personal computer, which is the RAM ceiling.
Let's break down exactly what that means for you listening. When Kathy Lang is testing this software, the IBM system she's using has 384K of RAM.
Not gigabytes.
No, 384 kilobytes of system memory.
To put that in perspective, a single high-resolution photograph on your phone today might be 10 times larger than the entire memory capacity of that machine.
Wow.
And that 384K had to hold the operating system, the application itself, and the data you were working on.
And this is where those integrated suites like Symphony walked right into a trap. Because of how they were architected, if you wanted to manage a database inside an integrated package, the software required the entire database to be loaded into the computer's RAM simultaneously.
It was an in-memory architecture. The theory was that RAM is exponentially faster than a mechanical disk drive, so keeping everything in memory makes sorting and calculating lightning fast.
Which is technically true, up to a very specific hard limit. I mean, think about it like organizing your company's physical paper records.
Okay.
The integrated suite approach is like trying to hold every single piece of paper, every invoice, every customer file in your two hands at the exact same time while you work.
And as long as you only have 20 or 30 papers, it works beautifully. You can glance at a spreadsheet, peek at a Word document. It's all right there in your grip.
But a business doesn't have 30 papers. A business has thousands. What happens when the stack gets too big for your hands?
Well, worse than just dropping them, the entire system crashes. When an integrated program in 1984 hit the RAM ceiling, it didn't gracefully warn you. It often just locked up the machine. You had to reboot, and you potentially lost whatever you hadn't manually saved to the disk.
Ouch.
The RAM ceiling wasn't just a technical bottleneck. It was a massive business liability.
So Ashton-Tate essentially bypasses this trap entirely with dBASE 3. They use a disk-based architecture. To stick with that analogy, dBASE 3 is like having an incredibly robust physical filing cabinet, which represents the hard disk or the floppy drive. Instead of forcing you to hold all the files in your hands, the software only pulls out the exact single record you need, lets you look at it or edit it in RAM, and then instantly files it back away in the cabinet.
It's a fundamental shift in resource management. By only reading what was immediately necessary, dBASE 3 completely decoupled the size of your database from the size of your RAM. Your data could be exponentially larger than your computer's memory.
But the defenders of integrated suites, like the Lotus Symphony fans, they would argue that reading from a mechanical disk is sluggish. A filing cabinet is slow. RAM is fast.
True.
And I was reading Kathy Lang's benchmarks on this in the PCW review, and the numbers stopped me in my tracks. She ran a test on an IBM PC XT hard disk, indexing 1,000 records on a 3-character field.
Let's hit the time.
It took 1 minute and 50 seconds. And then sorting 1,000 records on a 5-character field took 1 minute and 55 seconds.
Yeah.
Now, if I am sitting at my laptop today and it takes 2 full minutes for an app to sort 1,000 names, I am force quitting the app and assuming my computer's broken.
Yeah.
But Lang actually praises this speed in her review. Well, why?
Because context is absolutely everything here. In 1984, those execution times were a revelation. You have to consider the mechanics of what the computer was physically doing during that minute and 50 seconds.
Right.
The hard drive was spinning, the mechanical read and write head was physically jerking back and forth across the magnetic platters, reading a chunk of data, pulling it into that tiny 384K of RAM, sorting it, writing it back to the disk, and then fetching the next chunk.
It was performing a complex physical ballet just to sort a list.
Precisely. And Lang emphasizes that these times didn't look wildly inferior to the in-memory systems. That phrasing is key.
Wildly inferior.
Right. Ashton-Tate proved that with brilliant, hyper-efficient software engineering, you could manage the hard disk so effectively that the speed penalty was negligible compared to the massive benefit of limitless file sizes.
So they proved the integrated in-memory approach was basically a dead end for serious data.
Exactly.
So Ashton-Tate engineers essentially build a hyper-efficient V8 engine for data that bypasses the RAM limit. But building an engine that powerful under those constraints requires some serious architectural compromises.
Oh, definitely.
What were the actual physical limits of what a user could build inside dBASE 3?
Well, the limits were actually dictated more by the MS-DOS operating system than the software itself. Practically speaking, dBASE 3 allowed for up to 1 billion records per file.
A billion records in 1984.
I mean, it was a theoretical limit, of course. You'd run out of physical disk space long before you hit a billion records.
Right, on a 10-megabyte hard drive.
Exactly. But functionally, for a business user, the capacity was limitless. However, the structural dimensions of the database were rigidly defined. You were limited to 128 fields per single record.
Which means 128 distinct columns in your spreadsheet, to use a modern comparison.
Exactly. And critically, you could only have 10 data files open at any one time. In fact, the total system limit was 15 open files simultaneously, which had to include all your background index files and format files.
So you couldn't just have messy, sprawling databases. You had to act like an architect, planning exactly which files needed to talk to each other and explicitly closing them when you were done.
It forced discipline, but where Ashton-Tate really showed their architectural brilliance was in how they handled text. This is a massive breakthrough over dBASE 2.
Yes, the memo fields. This caught my eye because it solves a problem most people today don't even realize exists.
It's a great feature.
In the older dBASE 2, if you created a field called, say, customer notes, and you told the system you wanted to hold 500 characters, the software would permanently reserve a 500-character block of physical disk space for every single record in your database.
Regardless of whether you actually typed anything in there or not.
Exactly. If the note just said none, or if it was entirely blank, the disk still cordoned off 500 characters of space. In a world where your entire hard drive might be 10 megabytes, wasting blank space across thousands of records was a catastrophic waste of resources.
It was structural inefficiency. The rigidity that made databases fast also made them incredibly bloated when dealing with variable length text.
So dBASE 3 introduces these memo fields, and the mechanism they use to solve this bloat is brilliant. Let's look at the mechanics of that 10-character pointer, because it's like a masterpiece of digital sleight of hand.
It really is. It's the introduction of dynamic storage allocation to the consumer level.
Right. Instead of wasting 500 characters of space in the main database, dBASE 3 only takes up 10 characters. It places a tiny 10-character pointer inside the main record. Think of it as a set of map coordinates. That pointer directs the software to a completely separate, related file on the disk, a .dbt file, where the actual text is stored.
And that separate text file only expands the exact size of the words you actually type. If you write a 10-word note, it only takes up 10 words of space.
But think about the mechanical toll it takes on the hardware.
Oh, it's intense.
The disk drive literally has to spin a magnetic platter, move a mechanical arm, read those 10 characters in the main file, parse that it's a map coordinate, and then physically detach its attention, move the mechanical arm to a completely different sector of the floppy disk or hard drive to read the text file and pull it onto the screen.
And do it all instantly.
Right. The fact that they made this fast enough to be usable in real time is wild.
But it preserved the integrity and speed of the primary database. Because the main file remained rigid and predictable, just a clean grid of fixed-length data and those 10-character pointers, the indexing and sorting engines could blaze through it without choking on massive paragraphs of text.
So the bulky data was kept entirely out of the way until the user explicitly asked to see it.
Exactly. And when you did want to see it, the built-in editor let you type up to 4,000 characters. But Lang notes something even crazier in her review.
What's that?
If you bypassed dBASE's internal editor and hooked it up to a conventional external word processor, your memo field could be virtually unlimited. She cites a maximum of 512,000 characters per record.
Which is roughly the length of a Russian novel, just seamlessly attached to a single database entry.
Yeah, pretty much.
I see the technical achievement, but honestly, I have to play devil's advocate here for a second.
Sure.
I'm putting myself in the shoes of a manager paying £495 for this software in 1984. You're telling me I have to architect my database, understand file limits, grasp the concept of 10-character relational pointers, and then, if I want to write a long memo, I have to literally exit the editor, fire up a completely separate word processing program, link it back to my dBASE file, and manage both interfaces.
It's a lot.
Was Lotus Symphony actually right to prioritize user-friendliness, even if it sacrificed scale?
Right.
Because this workflow sounds incredibly clunky.
It's a very fair critique. I mean, for a novice, that workflow is undeniably intimidating. But you have to separate the casual user from the power user. Ashton-Tate wasn't building a digital Rolodex for the front desk. They were building an enterprise engine. For a business that needed to track complex inventory across multiple warehouses, the clunkiness of setting up an external word processor was a tiny tax to pay.
A tax for what?
For the sheer power of not corrupting your main database index with variable length text, the priority was data integrity at scale, not ease of use on day one.
It's the eternal trade-off in software design, isn't it? Convenience versus absolute capability.
Always.
And speaking of capability, Lang's review highlights a seemingly minor addition that apparently made database administrators just weep with joy, which is the new data types. Specifically, dBASE 3 introduced a dedicated date format.
The standard American date format, month, day, year.
It seems almost absurd to us that this was a feature worth praising. We just take it for granted that a computer knows what a date is.
We do, but before this standardization, dealing with chronological data was a total nightmare. In older systems, users often had to enter dates as arbitrary strings of plain text or as just raw numbers. If you typed January 5th as text, the computer couldn't sort it chronologically against February 2nd because F comes before J in the alphabet.
So the computer's just sorting letters. It has zero concept of time.
Exactly. By creating a distinct and forced date type, dBASE 3 didn't just standardize data entry, it introduced a whole battery of mathematical functions associated with time.
Like what?
Well, you could suddenly ask the database to subtract one date from another to find out exactly how many days an invoice was overdue. You could pull the numeric day of the week to analyze sales trends on Tuesdays.
Wow.
It transformed dates from static text into dynamic, calculable logic.
Which fundamentally changes what a business can ask of its data.
Mm.
So we've explored the engine, we've seen how it bypassed the RAM limits and handled data types, but an engine is useless if the driver can't steer it.
Very true.
How are users actually supposed to interact with this architecture on their glowing green CRT monitors?
Well, Ashton-Tate knew they had a reputation for being user-hostile after dBASE 2, so they attempted an olive branch for novices. They introduced the Assist menu.
Right, I saw that. You could press the F1 key, and it would bring up a series of nested menus to kind of guide you through basic tasks.
It was a visual crutch, but Kathy Lang makes it very clear in her review that this wasn't where the real action was.
No.
Not at all. The Assist menu was training wheels. The pros, the people actually building systems, they lived entirely in the command line.
But why? If the menus are there, why type raw code?
Because menus restrict you to the options the programmer thought you might want. The command line gives you granular, absolute control over the machine.
Oh. And Lang details the specific, powerful editing commands that developers relied on. It's really fascinating to look at the vocabulary of this software.
Yeah, the verbs are very specific.
Right. You had append, which is a blunt instrument. It just dropped you to the very bottom of the file to add brand new records. Then you had edit, which allowed you to call up a single specific record to alter it.
And you could locate that record by scrolling manually, searching by a key value, or even commanding it by its exact physical record number in the database index.
But then you get to commands that act on data at scale. Change was incredibly powerful.
Oh, change was a game changer, no pun intended.
It allowed you to amend a specific set of records based on a logical condition. You didn't have to find the records yourself. You could just tell the system, change the status code for every customer who lives in London and hasn't ordered in 6 months.
It's the automation of maintenance. But for actual continuous data entry, the interface breakthrough was the browse command.
Yes, Lang spends significant time on browse. She describes it as a full-screen editing mode. And remember, this is an era before the graphical computer mouse is ubiquitous.
Right, it's all keyboard navigation.
You are navigating a text-based grid. Browse let you see several records on the screen simultaneously, like a dense spreadsheet. But the brilliant part was the ability to pan and freeze.
Which addresses a fundamental human visual limit.
Exactly. Imagine a database record that has 40 columns of information. Your physical monitor can only show you maybe 6 columns at a time.
If that.
Right, so if you scroll to the right to update a phone number, the customer's name on the left disappears off the edge of the screen.
Yeah.
You literally forget whose phone number you are typing.
Browse solved this by allowing you to freeze certain fields on the left side of the display.
Yes.
You could lock the account number and customer name in place while you panned horizontally across the rest of the record to update distant fields.
We use freeze panes in Excel today without even thinking about it. But implementing that in a text mode MS-DOS environment in 1984 was a radical piece of interface design.
It really was.
It proved they were thinking about the cognitive load on the human data entry clerk, not just the logic of the machine.
But the true leap forward wasn't just visual, it was relational. If we connect this to the bigger picture, the reason dBASE 3rd became an enterprise standard was its ability to make different files talk to each other dynamically.
Okay, let's get into that.
We have to look at the update command.
This is where the database stops being a passive filing cabinet and starts doing the heavy lifting. Lang gives a fantastic practical example from her testing.
I love this example.
Imagine a standard 1984 small business. You have two distinct database files. File A is your main inventory. It holds your current stock levels, telling you exactly how many widgets are sitting on the warehouse shelf.
Okay.
File B is your daily transaction log. It records every order that came in today, telling you how many widgets you just sold.
So in older software, to reconcile these, a human being would have to print out the daily orders, look at the physical printout, go into the inventory file, and manually type in the new subtracted stock levels one by one.
A completely manual, error-prone chore.
Exactly.
But with the update command, you could formally relate these two files together based on a common key, like the product ID.
Right.
You can instruct dBASE 3 to scan the daily orders file, find the corresponding products in the main inventory file, and automatically perform the arithmetic to subtract the sold items from the stock levels.
It dynamically reconciled the data, and this was a massive upgrade from dBASE 2.
How did dBASE 2 handle it?
Well, in the older version, you could relate files to replace data or to add new records, but you couldn't easily perform mathematical subtraction across related data sets.
So the addition of arithmetic updates across relational files is the conceptual leap toward the fully integrated supply chain software we use today. You are building systems that react to new data automatically.
But that automation requires the user to speak to the machine with absolute precision. The computer will do exactly what you ask, which means your requests must be flawless.
And this is where the learning curve becomes a cliff. To filter data and run these updates, users had to master strict Boolean logic.
Yeah, it's true.
Lang gives us a beautiful artifact in her review, which is the exact string of code required to perform a specific search.
Let's hear the syntax.
If a user wanted to filter their database to find a very specific demographic, they couldn't just type, find single people with blue or brown eyes.
That would be too easy.
Right. They had to type this exact command. For marstat equals single, dot and dot, parenthesis, IE underscore CLR equals BL, dot or dot ELO E, underscore CLR equals BR, parenthesis.
To a layman, that looks like algebra, but to a developer, it is beautiful logical.
It is algebra. You are forcing the user to map out human concepts into rigid mathematical operators.
What is fascinating here is the permanence of this logic. The use of brackets to group conditions, the reliance on operators like .and, dot and dot, or dot. This syntax functions almost exactly like modern SQL queries used by data scientists today.
Wow.
Ashton-Tate was teaching an entire generation of business administrators how to think like compilers. You have to group conditions perfectly so the machine doesn't execute the OR before the AND and give you completely corrupted results.
The machine is incredibly logical, yes. But sometimes the machine's logic clashes violently with human language.
Oh, constantly.
Which brings us to one of my favorite details in Lang's entire review, the semicolon bug.
Ah, the leaky abstraction of the semicolon.
It's hilarious because it's such a specific artifact of how command line software was constructed back then. In the dBASE 3 interface, if you were typing a highly complex Boolean query, like the one we just discussed, and you physically ran out of space on the screen's command line.
You hit the edge of the screen.
Right. You needed a way to tell the computer, hey, don't execute this yet. This command isn't finished. It continues on the next line.
You needed a line continuation character. This is a standard convention in programming languages.
Right. And Ashton-Tate chose the semicolon. If you typed a semicolon at the end of a line as code, the system knew to keep reading the next line as part of the same command. Functionally, it worked perfectly in the code editor.
But the problem arises when that logic bleeds into the user's actual data.
Exactly. Lang notes that when she used the built-in report generator to print out her databases, she ran into a massive headache.
What happened?
If one of her text fields, say a company name or a book title, happened to actually contain a semicolon, the report generator's parser would see it, panic, assume it was a code continuation symbol rather than just punctuation, and violently force a new line right in the middle of her printed document.
The parser fundamentally misunderstood the context of the character. It couldn't differentiate between a semicolon as an operational command and a semicolon as a piece of human punctuation.
Lang writes that it drove her crazy, especially dealing with titles that naturally use semicolons. She had to dig into the system settings to see if she could redefine the continuation symbol to something obscure just to get her reports to print cleanly.
It's a perfect example of early software friction. The gears of the underlying code are constantly poking through the dashboard, snagging the user.
Yes, exactly.
But here is where we must shift our perspective. Because while those exposed gears were annoying for printing a report, those exact same gears are what made dBASE one of the most important software platforms of the decade.
Okay.
We are looking at the ancestor of modern automation.
And this is the turning point of the deep dive. Because dBASE 3 wasn't just a digital filing cabinet, and it wasn't just a command line tool for sorting lists. It was a full-blown software development environment. Lang calls these the tailoring commands.
Right. It allowed you to write programs that manipulated the database autonomously. You weren't just typing commands one by one and waiting for the result.
Right.
You could write a script, a whole list of complex commands, save it to the floppy disk, and instruct the computer to execute the entire batch sequentially.
And to make those scripts intelligent, Ashton-Tate gave users access to foundational logic operators. We are talking about do-while loops, if-else end-if statements, do-case commands.
These are the molecular building blocks of computer science. For anyone listening who writes code today, whether it's Python, JavaScript, or Ruby, these concepts are identical.
Totally.
An ALSE statement lets the script make a decision based on the data it finds. If the invoice is overdue, apply a late fee, else do nothing.
And a do-while loop tells the computer to repeat a specific task relentlessly as long as a certain condition remains true. Like, do this update process while there are still unread records in the daily log. You are literally teaching the database how to think and act on its own.
Precisely. And Lang's review meticulously notes that developers could execute these command files in batch mode, pass parameters dynamically between different files, and utilize up to 256 memory variables.
The variables that could be designated as local to a specific script or global across the entire architecture.
That level of state management mirrors modern scripting environments perfectly. The user had evolved from a data entry clerk into a systems architect.
And they didn't just architect the back-end logic, they could build the front door. Developers use these logical tools in conjunction with a specialized utility included in the package called dformat.
Dformat was a bridge between the code and the human.
Lang describes dformat as a paint-to-screen program. Instead of forcing a user to stare at a blank command prompt, a developer could use their keyboard to literally draw boxes on the screen, place custom text prompts, and position data entry fields at exact row and column coordinates.
Which means the developer could use dBASE 3 to build a completely bespoke menu system. An end user at a company might sit down at their PC, turn it on, and never even see the dBASE 3 logo or a command prompt.
Wow.
They would just see a custom-built, menu-driven inventory application tailored exactly to their business terminology, running flawlessly on top of the dBASE engine.
You were building standalone applications inside a database shell.
Exactly.
But I have to stop and ask the obvious question here. I'm reading Lang's review. I'm looking at do-while loops, 256 memory variables, local and global scope, strict Boolean algebra.
Yeah, it's dense.
I'm a small business owner in 1984. I bought an Apricot PC to track my shoe inventory. Is a beginner really going to sit down, crack open a manual, and figure out how to program a nested do-while loop just to see how many loafers they have in stock? Sounds like completely absurd.
It is a massive intellectual leap. It's asking a civilian to learn structural engineering to build a shed. But Lang's review actually addresses this exact anxiety.
She does?
Yes, she evaluates the learning curve, and she praises Ashton-Tate's documentation highly. They knew exactly how much they were demanding of the user.
So how do they bridge that gap?
Well, the manual wasn't just a dry dictionary of syntax. It was structurally divided into 3 distinct tools: a step-by-step tutorial for the absolute beginner, a dense reference section for the programmer, and a comprehensive glossary with a highly detailed index.
And we forget that a good physical index in a manual was worth its weight in gold before digital search bars existed.
Absolutely. But the stroke of genius was on the second floppy disk. Ashton-Tate didn't just provide the software engine, they provided a fully functional example. The package included a complete, pre-built, simple accounting suite, written entirely in dBASE 3 command files.
Oh, they gave you the blueprint.
Exactly. You
Yeah.
didn't have to stare at a blank screen and invent database architecture from scratch. The tutorial manual walked you through these sample files line by line, showing you exactly how the inventory file related to the ledger file and how the do while loops automated the updates.
So a persistent business owner could just reverse engineer the sample code. They could copy the accounting suite, change credits to shoes, and slowly teach themselves the underlying principles of relational programming.
They were essentially tricking business owners into becoming software engineers.
And it worked. An entire cottage industry of dBASE consultants and bespoke business applications sprang out of that exact learning process.
But maintaining those applications, well, that brings us to a harsh reality, because being a software engineer in 1984 meant you were also the janitor. Data doesn't maintain itself.
It really doesn't.
Yeah.
And the friction of the era meant a lot of manual housekeeping.
A lot.
We talked earlier about how fast the indexing was, 1 minute and 50 seconds for 1,000 records. But there's a catch that Lang highlights. The software did not automatically index everything all the time in the background.
Because background indexing would consume precious processor cycles and eat up that tiny 384K of RAM, slowing the entire machine to a crawl.
Right. So Ashton-Tate put the burden of vigilance entirely on the user. When you opened a database file to add new records, you had to explicitly tell dBASE 3 the names of the specific index files you wanted to keep updated using the USE command.
It required immense discipline. If you opened your main file, forgot to activate the corresponding index, and proceeded to add 50 new customer records,
Your index is now hopelessly out of sync with the physical data on the disk. The next time you try to search for a customer, the software will look at the broken index and tell you they don't exist.
Exactly. You had to constantly monitor the state of your own files. The machine assumed you knew exactly what you were doing at all times.
Which makes their approach to security absolutely hilarious in retrospect. I was reading the section on file protection, and Lang bluntly notes that the security features were mostly just self-help procedures aimed at preventing accidental deletion.
It was security against your own clumsy keystrokes, not against malicious hackers.
Yeah, exactly. There's no complex encryption here. But the way they handled deletion is fascinating. In dBASE 3, if you delete a record, it wasn't actually erased from the disk.
It was merely flagged.
Right. An asterisk was placed next to it. It was marked for deletion, but it still sat there, taking up physical space on the disk, slowing down your searches. To actually get rid of the data and reclaim the disk space, you had to type an explicit housekeeping command. Pack.
Pack would go through the file, locate the flagged records, physically expunge them from the disk, and rewrite the entire file to compact the space.
It was a vital safety net. You could undelete things before you packed them.
Yeah.
But then there was the nuclear option.
Ah, yes. The ZAP command.
If you typed ZAT, it bypassed the flags, bypassed the safety net, and violently wiped the entire contents of the database file completely clean in an instant.
It's ruthless.
Lang notes that the software does pause to ask for confirmation before executing it, thankfully. But it's just such an aggressive, almost cartoonish command name for a serious business tool. Like, hey, what happened to the Q3 earnings database? Oh, I accidentally ZPapped them.
It perfectly encapsulates the philosophy of the era, complete terrifying authority.
Yeah.
The user was granted the power to build intricate, deeply complex automated systems and the absolute power to instantly obliterate them with 3 keystrokes.
But a database couldn't survive in isolation, no matter how powerful it was. It needed to talk to the rest of the office.
Interoperability was the final frontier for dBASE 3. Ashton-Tate recognized that the 1984 office was fractured. Users relied on multiple disconnected tools.
And Lang highlights a massive under-the-hood upgrade in dBASE 3 regarding how it interacted with the METS itself.
This is a big deal.
If your system had enough memory available, which was a big if, you could actually execute standard DOS programs from within the dBASE 3 environment.
This solved a massive workflow bottleneck. In the dBASE 2 era, if you were working in your database and suddenly needed to format a new floppy disk or run a quick DOS utility, you had to completely exit the database program.
Which takes time.
It takes forever, and developers hated that, so they built these clunky .bat file workarounds, essentially writing crude batch scripts in DOS just to hand control back and forth between the operating system and the database.
It was fragile and frustrating. dBASE 3 smoothed that friction out. You call the operating system, run a command, and seamlessly return to your active database without losing your place.
But the real prize of interoperability wasn't running DOS utilities, it was sharing the actual data. A database is a silo unless you can extract the information.
Right.
dBASE 3 allowed users to export their data to the outside world. It could read and write fixed-length ASCII files as well as comma-delimited formats.
Though Lang did discover a notable bug during her extensive testing.
She did, and she documented it for everyone.
Yeah, she notes that while the fixed-length ASCII export worked perfectly, she could not, for the life of her, persuade the software to read beyond the very first field of her comma-delimited files.
A classic parsing error in an early release.
Exactly the kind of frustrating, undocumented glitch that early adopters just had to power through. They likely had to write their own complex scripts just to clean up the exported data.
Very likely.
But when that export capability functioned, it was sheer magic for an office. Why? Because it allowed the database to push names and addresses out to the word processors of the day. Specifically, it allowed you to push data into WordStar for mail merge.
And we cannot overstate this. Mail merge in 1984 was the killer app of office automation.
It was a superpower.
The ability to use dBASE's Boolean logic to filter a list of exactly 200 past due clients, export that highly specific list via a comma-delimited file, and feed it into WordStar to automatically print 200 perfectly personalized collection letters.
Incredible.
It was science fiction transitioning into mundane business reality. It redefined office productivity.
But this raises an important question for us today.
It really does. When we look at Kathy Lang's review, and we see how desperately users needed interoperability back then.
The grueling effort required to push data from dBASE to WordStar via raw text files just to get two programs to communicate.
Exactly. It reveals a fascinating and honestly somewhat depressing trajectory in software history.
Also?
Back in 1984, developers were building bridges out of raw ASCII text just to overcome hardware isolation. They wanted their tools to talk. Today, we have robust, instantaneous APIs that can connect thousands of applications globally in milliseconds, yet we constantly find our personal and business data trapped inside proprietary sauce silos that outright refuse to speak to each other.
Because keeping the data trapped inside their specific ecosystem is their business model.
Precisely. The friction is no longer mechanical, it's commercial. We have entirely solved the technical problem of interoperability that Ashton-Tate and Lotus were fighting over. But we have somehow regressed in the fundamental philosophy of who actually owns and controls the data.
That is a phenomenal point.
Yeah.
In 1984, the limit was a spinning magnetic disk. Today, the limit is a corporate terms of service agreement.
Beautifully said.
So to bring this massive journey all together for you, today we took a deep dive back to the constraints of 1984 through the lens of Kathy Lang's review in PCW magazine. We examined the brutal RAM ceilings that trapped the integrated suites like Symphony.
And we explored exactly how dBASE 3 bypassed those limits by utilizing ingenious 10-character pointers and treating the disk drive like a hyper-efficient filing cabinet.
We dissected the mechanics of its precise, unforgiving command line interface. We saw how tools like the browse freeze panes and the relational update command gave early developers unparalleled granular control over data manipulation.
And crucially, we uncovered how its internal automation tools, the dway loops, the strict Boolean algebra, the custom deformat screen painting, didn't just create a digital Rolodex.
No, they laid down the exact programmable logic that serves as the bedrock of modern database architecture today. dBASE 3 didn't just store data. It forced users to architect logical solutions.
It remains a masterclass in how severe physical constraints breed brilliant software engineering.
It absolutely does. Thank you to you listening for joining us on this exploration of the invisible mechanical foundations of our data-driven world. But before we sign off, I want to leave you with one final thought to mull over.
Okay.
In 1984, the ultimate power play for a computer user was overcoming the physical constraints of a laser-burned floppy disk and 384K of RAM to write a custom script that simply related two datasets together. They had to learn the logic of the machine.
They had to.
Today, we sit on the absolute opposite end of the spectrum. We have virtually limitless cloud storage, near-infinite memory, and AI algorithms doing our sorting silently in the background. But as we increasingly rely on seamless no-code apps that completely hide the underlying Boolean logic and relational algebra from us, are we actually less empowered to truly understand, manipulate, and control our own data than a dedicated dBASE 3 developer was 40 years ago?
It's a great question.
Think about that the next time an app updates flawlessly in the background without you ever seeing the code. Until next time.